Well, welcome back. Today we're going to be into 1.6. We're going to talk about relations and functions. And one of the biggest things we want to figure out today and be able to determine is what makes a relation a function. That's kind of our key goal for the day. All right, so now a relation is just kind of a pairing of inputs and outputs. A lot of times we say, okay, I put this in, I get this out. Very common, we'll see that as a ordered pair, x, y. Put the x in, the y is what you get out. We're going to use the idea of what's a domain and a range. So domain is your input, which is typically your x's, and your range is going to be your output, which is your y's. Okay, so all those are kind of used interchangeably as we look in here. One thing that we had back in the old days of texting on your phone, you didn't have a full keyboard or smartphones and that kind of thing. So a lot of times what you do is you assign one of the digits to, it would be assigned an A, B, or C. And so again, the domain in this case is a 2. That's it. That's all you have. And the range would be A, B, or C. Okay, so input, output is what you get there. Kind of interesting kind of way of doing that. All right, so now let's take a look at here. If I were to write the domain, now when we do that, I always like to kind of go with domain, put a little colon, put a little fancy brace there, and just write down in roster notation, write down what that is in this case. So we'd have the domain would be 100, and just the x values, so 120, 140, 160, and 180. And then the range, just use an R, and we'll use a fancy bracket. Now, once you'll see here that the range, we have a 5, we also have a 5 again. So you don't have to list it twice. And most of the time, we like to list them in order. We go 5, again 6, we don't have to list that twice, and then we have a 12. So there's your inputs, your range, domain, and your outputs, and that's your range as we kind of write those. Okay, so again, as we go domain and range, we're going to look at doing those repeatedly here. Let's try a few more other situations here. I think in this case, we're going to have a little graph. All right, well, the domain are the x values. Okay, so I'd go, -1, -2. I'd say domain would be -2, -1, 0, 1, 2. Looks like we end over there at 3. Good way to do it, listing it in roster notation. Now the range, let's start at the bottom. Looks like we start here at -3, -2, -1, 0, 1, and 2. So again, we have the domain and the range. All right, so we have just dots listed there, so we want to list those out as we list those. Okay, you can see it right from the graph. Pretty easy peasy, lemon squeezy. Okay. Now, as we mentioned before, on a telephone, you have some different things that you might be trying to type out. You have a 6, a 2, an 8, and a 4. Well, if someone says, hey, I did those, what message am I trying to send? Well, you have to kind of look. Well, there could be 3 choices, M, N, and O. Could be an A, B, or C, T, U, V. Well, I think we kind of know what's going to happen here, is that we're probably going to go with math, because what else would you be talking about, right? So again, it can be kind of confusing there when, if you have an input, if you have multiple outputs, it could be quite as confusing as we go here. Now, a function is when, okay, I type in an input, I put in an input, I can only get one thing out of it, okay? So it can only go to one thing, and that's it, that's all that you can go to. That makes a relation a function. Okay, so our previous example up here, this is not a function because 6 could go to M, N, and O, okay? It has to go to one specific thing, can't have multiple choices as we do that. Okay, so here's some examples here. Again, as we mentioned, 2 is associated with letters A, B, C. This is not a function because, well, you have multiple choices. Well, this is a function. This is kind of tricky. A goes to 2. Yeah, there's only one thing that A could go to. Well, B also goes to 2. So we can have different things from the input go to the same output, but we can't have the same input going to different outputs. Okay, so that can be a little tricky. Let's look at some actual examples of maybe some things and see if that helps make it a little more sense. Determine if it's a function. Items in a store to their prices. So if I go over to Cub Foods and I get a box of Cheerios, if I go over there today, it should be just one price. So today, whatever the date is today, if I go over there, this is the price of a box of Cheerios. They usually don't change prices during the day. Next day they might, but typically during the day it's 1. Types of fruits to their colors. Let's just think of apples for a case. If I told you I had an apple, do you know for sure which color it is? And the answer is no. Most of them are red, but you could have green, you could have yellow. Okay, so again, you don't know if you have that. So again, that would be an example of something that's not a function because it has multiple outputs that you could have. All right, now here's the fun part. From a graph, we are going to be able to tell if something is a function if it passes the vertical line test. All right, now if I make a vertical line through the graph, and again, we're going to make a little sound effect here. We're going to be like Miss Piggy here. We're going to make a vertical line. We're going to go hi-ya, and go right through the graph. If it only goes through in one spot, that means it's a function. So you can see here, hi-ya, hi-ya. Doesn't matter where I draw the line, it only goes through one spot. Now this example over here, you can see, hi-ya, it goes through two spots. So it is not a function. Okay, that's how you can tell. All right, so here's a couple to practice. These are the fun ones to do. All right, so by the vertical line test, we're going to give it a good hi-ya. We want you to work on that. So we give it a hi-ya, and I don't see any spot where that line would go through more than one spot. So again, we would say that this would be a function. Okay, quick, easy way to tell. All right, now this one, hi-ya. Oh yeah, goes through two spots for sure. Yeah, everywhere it just kind of goes through two spots. You only need one spot. Okay, so this would not be a function if we had that one. This one, hi-ya. Yeah, that would pass. That's a function. Only goes through one spot. Yeah, that one works. All right, and then the last one here. Okay, hi-ya. Oh, this is a tricky one. Hi-ya. Oh, there is a spot right here. Oh, that's the one spot where it hits two of those. It's when x equals 1. Because if I put a 1 in, it could be 2 or it could be -2. So this would not be a function. Now the question might be, well, Mr. Boone, are you going to try to trick us? Well, sure I am. So what would happen if this one wasn't filled in? What if this one was an open circle and this one was a closed circle? In that case, yeah, that would be, because this doesn't include the endpoint, that would be a case where it is a function. But because they're both closed, that's the one spot that it fails, that vertical line test. Okay, so have some fun, practice your hi-yas, and remember, in order to be a function, each input can only go to one output. That's how we know if it's a function. Okay? All right, that's it for 1-6. Until next time, I'm Mr. Moon.